Hello and welcome to today's event, How AI and IoT are Reinventing Operational P3s, presented by ServiceWorks Global. My name is Adam Straker. I'm Director of Sponsorship and Member Services here at the Canadian Council for Public-Private Partnerships, and it's my pleasure to introduce our session and speakers for today. Today's webinar is the latest event in our new Infrastructure Innovators. These free events are stakeholders from the infrastructure sector and beyond to learn about new opportunities, innovations, ideas, and technologies that have the potential to transform the infrastructure sector. Where the rubber hits the road with these events is that they are presented by the innovators and the game changers themselves, all of whom will be ready to answer your questions and will be available to discuss in more detail. Now, before I introduce our speakers, I would like to draw your attention to our Q&A and polling features on our event platform. Now, if you look to the right of your screen, you'll see a vertical line of icons. The top is our messaging icon. Please feel free to say hello to your fellow attendees. Beneath the messaging icon is a little box with a question mark. At the end of the presentation, there will be time for questions, so please pop questions for our speakers in here or vote for any existing questions that you would like to see answered. Beneath the Q&A icon is our polling feature. It looks a little bit like a bar graph. There will be polling questions posted here during the course of the presentation, so please be sure to click on the icon and provide your thoughts. Our speakers will let you know when the question becomes available. While Canada has one of the most successful P3 markets in the world, its future is not without its challenges. A complex model already, and now stakeholders face increasingly challenging operational demands such as budgetary pressures and net zero targets. How can technology ease this pressure without becoming yet another cost? Here to tell us how increasingly intelligent and accessible technologies like artificial intelligence, Internet of Things, and building information modeling can transform P3 operations are our speakers for today, Matt Broman, Samantha Fuller, and Liz Cummings. Matt Broman is the CEO of ServiceWorks Global and is responsible for leading SWG's growth and positioning in Canada and internationally, with more than 20 years of experience in IT and FM-related operations and having held several board-level positions. Matt is passionate about developing technology-related products and services in the FM and P3 sector. In recent years, Matt has been driving the implementation of AI, BIM, and the digitalization-related services across SWG's territories. Samantha Fuller is the International Managing Director of ServiceWorks Global. Her work sees her collaborating closely with FM and P3 stakeholders across every industry sector, understanding and solving problems such as around asset management, workplace productivity, and maintenance strategy using experience gathered over 25 years, combined with a deep knowledge of software and technology development. Liz Cummings is solution consultant with ServiceWorks Global and has extensive knowledge of CMMS and P3 performance management software. As an FM user previously in her career to delivering QFM software across ServiceWorks Global's global client base. Liz has helped implement some of SWG's most high-profile projects, excelling in contract mobilization, end-user training, and even CMMS multicultural training to ensure users from different cultures work together efficiently. 25 years of experience working client-side and as a software provider has given Liz a unique insight into how technology can help address myriad different FM and P3 challenges. Over to you.
Thank you, Adam. So just as Adam said, we're here to talk about and discuss AI and IoT and how it's working with our P3 contracts here in Canada. Just to give you a bit of background about who we are as well. As Adam said, Matt is our CEO, I'm the MD, Liz is looking after our consulting and professional services group. You'll see here there's a QR code on the bottom right corner. If you scan that QR code, it will take you to our white paper, which you can then download, covering this exact topic. So, who are ServiceWorks? We are a global organization. We have offices across all regions. Our experience and shared knowledge across these regions provides us with the ability to compare contracts from around the world and identify changes and trends to the nature and requirements of P3 contracts. On a global basis, we have 40 plus contracts where we've taken brownfield sites and built a payment mechanism and implemented that to that existing contract. On average, a contract term for a P3 is 20 to 30 years. And the number of KPIs vary for those contracts depending on the nature and the services provided. Also, the age of the contract. Newer contracts tend to be more complex and often have more KPIs. We've seen some contracts with as few as 40 KPIs and others with as many as 130 KPIs. Mats, do you have any comments on digital twin?
I have a little bit troubles to see the screen actually now, but I'm trying to so I can see now. Yeah, from now I can see the screens again. Okay, thank you. Yes, I will just talk you through like a definition of a connected digital twin, because there are a lot of explanations of what is a connected digital twin, or is sometimes we just talk about digital twins. From our perspective, we talk about from the design and build process, an as-built digital twin is delivered. And then we connect it to sensors and understand how the building and its assets are used, instead of just have as-built data. So the connected digital twin means that we have as-built data that is connected to sensors, so we can review how the building are used or the assets are used. And the connected digital twin also includes processes to keep it updated when replacing assets in the ongoing management of the building. So it's both how to connect it and also to replace and keep it updated in the maintenance operation processes.
Great, thank you, Mats. So moving on to our next point, or a little bit more about our presentation. We've got do P3s need reinventing? So the question then is, it's a very good question, which I'm sure a lot of people on this session are actually able to probably share some information as well. So to start off with, though, we're looking at P3s are changing, and we are seeing them change. There are new requirements, and they're being stipulated in the actual contractual documents. Basically, clients are demanding more. As the world changes, so do the needs of P3 contracts. For example, you've got KPIs that are related to sustainability, environmental reporting, such as CO2 emissions, offering benefits to the service providers for reducing carbon footprint in the form of a payment rebate, or allocation of points that can be used to offset future abatements. The idea then, what we are seeing is that there's improved collaboration between the client and the service provider who's delivering that service for the 20, 30 years to allow the contracts to evolve and grow as our world changes. Liz, you've worked on P3 contracts globally. How does Canada compare to other regions you've encountered?
Thank you, Sam. To date, there are 291 active PPPs in the country with a value of over 139 million, making Canada one of the leading users of PPPs globally. Of the 200 P3 projects, there is a global split, 30 plus in Australia and New Zealand, 2. In the Middle East, we have 40. In the UK and Ireland, 50. In Canada and 14 in the US, sorry. The number of KPIs per contract varies depending on the age of the contract and the nature of the services provided. Operational phase spanning 20 or so years presents a host of challenges, and the way to deal with them is evolving. If the contract was kept in the drawer and never looked at, that was considered a good thing. Using data to meet KPIs, improve relations with the public sector, spend less time arguing, more time doing the work. Next slide, Sam. Thank you.
Thanks, Liz. There's some interesting comparisons there that I think we can see on a global scale. We're now looking at greenhouse gas emissions. So from this perspective, there are a number of, again, global differences, but also some common threads. Matt, do you have any thoughts on managing the demand in Canada specifically around carbon footprint and these new contracts?
Yeah, so we can see according to the World Bank's report about investments in low carbon infrastructure, we can see that approximately 70% of the global greenhouse gas emissions emanate from infrastructure construction and operations. So that is also that we can see that in 2023, Canada's population tipped over 40 million. Is recording the fastest rate of annual growth since 1957. And when more homes need to be built to accommodate this sharp population rise, and the Canadian Urban Institute has claimed that the increase of the number of homes means that Canada must invest in more infrastructure. And that means more bridges, highways, public transit links, schools, and hospitals. However, this means all the investments in this infrastructure also means that we will have the level of infrastructure comes the potential of environmental damage. So PPPs also have to must be leveraging the tackle to these challenges, and the incentives for the private sector innovation has to be there. And it could be helped with new technology. So we hope with this presentation today that we can discuss and see what new technology to bring to the table to be able to enhance this.
So basically, it's inevitable that new infrastructure development and construction will have an environmental impact. And PPPs are also receiving criticism for missing deadlines in the construction phase. But technology can improve efficiency in the operational phase. So what we must therefore do as those responsible for managing PPPs is to ensure they run as efficiently as possible in terms of energy consumption, asset performance, etc. The idea then is to minimize environmental impact as well as delivering value for money. They're being able to deliver a project and deliver the promises to the public is what is really important. We're going to start one of our polls now, which is on what technology do you rely on as your primary tool to manage operational phase, or the operational phase of your PPP contracts. And you'll see there is a on the right side of your screen, there's an icon that's a bit like a graph. And if you click on that, you'll be able to get the poll question and enter or select A, B, C, or D. And that'll tell us basically, will give us an idea of what's actually what you're using. And even if you're unsure, because you might be new to the market, or you are using a CMMS or spreadsheets, some other form of technology. We'll just give it a few minutes to see how that scores. So I can see here we've got a number of people are using CMMS with integrated payment. Few people using spreadsheets. I've got a few more votes for the CMMS with other technology. And a couple of unsures. Great to see though that there's no technology in place is yet to score any votes. So, all right. So we're looking at the moment, it is 50% using a CMMS with an integrated payment mechanism. We've got 20% using a CMMS with other technology. Another 20% using spreadsheets, and about 15% unsure at the moment. So that's great. Thank you all for participating in that review. All right, I guess that does tie into where people are at the moment and where we're going to jump to next with our next point, which is what are some of the common pain points and how we're going to deal with those. So there are some common pain points, and this is a very broad range of content here that we could touch on. It depends on the individual and their role within the P3 as well. So what I find is a pain point, Liz, a colleague who is working in a different department or different area, may not have the same. So it does depend on what is actually happening with that contract. And it's all relative to the actual contract and the site and the facility and the nature of the contract at the time. The complex nature of managing infrastructure projects over such a long life cycle only emphasizes that fact as well, because there are so many stakeholders involved. You've got multiple moving parts and therefore multiple possible areas where there could be particular pain points. One of the fundamental pain points, though, that we hear about is the lack of meaningful, actionable data. And then the question is, how can we improve if we don't know what's working or what's causing delays or what's costing us money? Matt, do you have any thoughts on how we could start using this with some of the technology we've got?
Yeah, so if you take it from a maintenance and operation perspective, the first step is to collect and structure all data. Hopefully, we come with in the new technology, we come through BIM models. It could come through spreadsheets and other things, but in the modern world, in the future, that should come from the BIM models with all the objects and geometry that it can bring. So the BIM model provides the CMMS with the defined maintenance object for the assignment, and the CMMS and its associated payment define the KPIs to be delivered within the scope of the assignment. But we can say that in general, there is a little visibility of long-term asset management, including the condition of assets, durability of materials, and energy efficiency. And similarly, a lack of data on the associated life cycle costs makes it difficult to uncertain whether a project is delivering value for money. Meanwhile, there is a shortage of meaningful, actionable insights for operators to learn from previous projects and share best practice, make accurate projections, and demonstrate both environmental and social values. So the most common uses for a facility manager are asset management and maintenance of environmental controls. And equipping a building assets with sensors allows the operator to detect factors such as stress, vibration, or temperature, or humidity. There could be different values there. And these environmental sensors, on the other hand, can monitor factors more closely related to the occupier or user experience, such as lighting in the room, or temperature, or occupancy. And these elements are no less crucial for parties' responsibilities for the operational phase of public infrastructure, including transit hubs and hospitals, where people are likely to associate a poor experience with the value of their receiving for their taxes. So understanding the conditions of an asset and when it's likely to fail is like the predictive maintenance we can talk about here. Is, for example, to lead more effective maintenance schedules. If parameters on the asset's conditions are preset, sensor can trigger an alert before the assets break down. So with a growing bank of real-time data, a schedule can be also developed that results in less under and or over servicing, minimal operation downtime, and savings and costs associated with the engineers traveling to site to fix problems. A challenge that any operator working across Canada's geography knows as well, because it's so big country and spread out.
Thank you, Mats. It's that was something actually that we picked up on as well. The spread of resourcing when we were at the CCPPP conference last week was contractors being used across the country from one coast to another, and is that actually the best use of resources, and how do we manage that? So particularly those resources with specialist skill sets. To move on now, though, to look at another area of P3 contracts is around managing payments. So while we have other aspects of the contract, the management of the payment itself is a critical part of the contract, and also one of the pain points that frequently get raised. Liz, you've been implementing P3 contracts for some time now, so is there something that you could share here with us, some trends that you're picking up on and what you're noticing within the more modern contracts?
Yeah, we often get new clients who are partway through their contract and have been managing the reports and calculating payments manually through spreadsheets, and it can take them days. And there's still the potential that they've accidentally miscalculated or transposed a figure, typing it in. Leading inaccurate figures, it could end up costing them more in deductions than it actually should. So a payment mechanism, or PayMech, is integrated within the CMMS, and each SLA and KPI is fed in line by line. It reviews the result of each service event over the month or period, and calculates the deduction for each failure, taking into account its weighting and any ratchets for continued failure or unavailability. As the data never leaves the system, it's completely accurate and auditable, meaning any queries about payments can easily be resolved, leading to better relations between public and private partners. The software also provides a trend analysis and alerts of impending failures so that they can be identified and rectified. And if there are multiple impending failures, the service provider can channel resources to resolve the one with the biggest priority or financial impact. As Matt just said, sensors can be integrated to give service providers a deeper insight into asset performance. Sensors can identify potential issues before they become identifiable to an engineer, so they can be serviced and prevent breakage, therefore leading to fewer deductions.
So Liz, while you've mentioned the use of sensors to better understand the asset's performance, do you envisage they will have a critical role in the management of environmental elements that we're now seeing appear in contracts?
As touched upon earlier, it's impossible to ignore the enormous pressures now associated with net zero, especially in public infrastructure projects. Infrastructure projects must align with Canada's federal net zero 2050 target. Subsequently, net zero is now incorporated into the contract language and technical requirements of P3 projects, making it a central component of the bidding process and pushing all new and existing projects to decarbonise across the life cycle. The combination of sensor data and AI allows operators to monitor their carbon emissions. measure to make improvements, and keep a record for all regulatory requirements.
Bit of a tongue twister,
Yeah.
that regulatory requirements. Thanks, Liz. So again, environmental new technology can help us with this, the management of these new contractual requirements. Risk and contract negotiations. So this is another area that was mentioned quite a lot at the CCPPP conference as well, managing risk. So the management of risk and contract negotiations, it is a critical component of the contract, particularly the earlier phases of a P3 contract. But they are ongoing factors which must be considered by all parties in order to form a strong partnership. Understanding areas where risk will be greater and how this can be managed are critical to successfully deliver, support, and maintain a contract. As I said, the 2 days at the CCPPP conference last week, risk was mentioned multiple times by multiple speakers and in some of the breakout sessions. The risk associated with the delivery of the contract in its entirety, down to specific aspects of the contract, such as resource churn, costs, abatement management, that it varied depending on who you were talking to. We often find that there is a reluctance to introduce new technology. Stakeholders can sometimes be risk adverse, risk to changing the status quo, and therefore it's a change management activity. It's important to engage with the business unit early on so that they have buy-in to the contract structure. And also the systems and how they're implemented. A key aspect of this is change management. So in an area which is often neglected when deploying a new system or implementing new technology, you really should have someone who is filling that change management role. It's also important to understand the requirements of the contract and then identify which solutions and tools can be used to meet these requirements. It's also important to flag where contracts may change. An example of this is where a contract may be varied to align with environmental reporting standards. So, as Liz said, the net zero requirements that are due in sometime between now and 2050, as they are implemented, contracts will change. Liz, could you share with us some of your experiences working on P3 contracts and implementations?
I have seen how technology can be implemented on both high and low visibility. By this, I mean implementing a mobile app or BIM module. These are visible for the end user to see and interact with on a daily basis. The low visibility solutions are integrations where there is data being shared between systems with little or no interaction from the end user. Integration with sensors and BMS systems feeds into the history of the asset and creates jobs automatically as triggered by the BMS or sensors management thresholds. We see clients raise concerns as to the need for automation, costs concerned, they will be replaced. The reality is we have seen the benefits of automation by allowing individuals to carry out their daily tasks without the distraction of ad hoc tasks and management of critical issues, therefore allowing them to do the work they've been employed to carry out. Recently, the use of tools similar to ChatGPT offered end users the ability to work more efficiently by integrating with CMMS systems. Users can quickly search for troubleshooting tips and solutions or confirm the parts to take to site to repair an asset and save multiple visits to site, reducing downtime and increasing resource productivity. This is particularly useful when there is a turnover of resources. Handovers become less critical and the onboarding of new resources can be streamlined.
Thank you, Liz. So I guess the key is working out what technology is actually relevant and useful, and then implementing that. One area, though, that we're finding, or we've seen a reluctance to embrace in Canada is BIM. The maturity of the contractual requirements, specifically around BIM, are not as established as they are in the UK and Sweden. Mats, you're from Sweden, so you're very familiar with BIM and working with that at that government level and municipality level. What are your thoughts on this reluctance to implement BIM or to invest in BIM in Canada that you've seen?
Yeah, thank you, Sam. So I can take the next slide, the 2 slides ahead, please. Take one more step. So from the BIM model perspective, or the BIM perspective, it is to explain the BIM model. It is a digital process that enables the creation of management of virtual 3D models of a building, and that includes all physical and functional characteristics throughout the building's life cycle. And the use of BIM is not only improved construction and property management processes, but it also contributes to achieving sustainability goals through more efficient use of resources, reduced energy consumption, and increased focus on the green buildings. And when I were at the conference in Canada, I reflected a little bit. There are a little bit of lack of standardization, how to deliver information. There are standards today, ISO standards 19650 is a standard to both structure BIM data in the construction projects, and it's also structure how to do the handover to the operation and maintenance phase of this. When I talk to some of the people around that, this is not every project deliver in their own standard. It might be that they can use some of the standards, but it's not broadly implemented in Canada. The difference in Europe is that is now taking place, and in UK that has been mandated to use BIM in new investments in projects in general, and they are also implemented in Sweden now, and it refers back to this ISO standard, how to deliver it, so we can be more efficient on that. And that also comes back to the sustainability goals. I think the biggest driver in the market now is the sustainability goals and how to be compliant with all the reporting requirements in accordance to new legislation in the EU, and I guess that will come related to the net zero goals that they put up in each of the countries. EU have mandated that be some requirements, reporting requirements that should take place here, and if we don't use BIM, that will be nearly impossible to reach those goals. And compliance must then be accounted for in ongoing management of the building, which means that the data created in the construction phase must be transferred to the management phase of the building. And we have to be able to compare the theoretical plan with the actual outcome. So the demands in the requirements demands that there will be some, how do we come down to this net zero approach, and that we also can compare that, how the actual outcome will be. So one of the biggest things now that we work with in Sweden is to have the right requirement from an operation management perspective of the buildings, so you can extract and make available the right data with associated geometries from the BIM models. So that is one of the key things to build up the as-built information that we then can connect to a connected digital twin. Can take the next slide, please. There are different views, of course, of this when we talk of this BIM in facility management. So it's important in the construction project, of course, and that is one of the enablers to create successful building projects to work with collaboration in the BIM methodology. In the phase of operation and maintenance is to make sure that we can have access to all of these, both data, but also geometrical presentation of the data in different user interface. And of course, it can be mobile, and we can take the next slide. It can be in the space solution that we want to have, and in the space solution that are also in the mobiles, we want to access more detail of the objects. So when you click on an object, for example, we can have specified details that comes from the BIM model. So from a maintenance and operation perspective, that might be that it's just an object that will be maintained and operated. But if you have to fix something and repair something, it might be that you want to have more details into this. And then we can just click on the object and get more detailed information from the BIM that will be helpful in the operation and maintenance phase. And the last slide here, just on the BIM, is related to it has also to be implemented in the operation and maintenance system that you use, the CMMS, should this be implemented. So you don't have to swap out to different solutions. It should be integrated in your ordinary user interface that you work on in the day-to-day process. So that is one of the key insights, I would say, that has been in Sweden. So it's not easy for a technician to swap between different apps and different technologies. That has to be implemented and integrated to the CMMS that is used for the projects.
Great. Thank you, Mats. So it's very clear that we are pushing ahead with the capability of technology. And we have some great use cases from our sister companies and our other regional departments that we can leverage off. Now, if we focus back on Canada, Liz, what are your observations and the use of BIM in particular, or BIM data, I should say, and the tools and the uptake from the industry? Are you starting to notice a change as contracts evolve?
So Sam, Canada is the only G7 country without a national BIM mandate, but influential bodies are now campaigning for this. The president of Building Smart Canada said that it is required. Typically, the main challenge is training, time and money. Country without a BIM mandate, but there are increasing calls for one. It's likely to become mandated in P3 contracts. And one of the key takeaways from a report, Open BIM Implementations for a Canadian Roadmap, developed by Building Smart Canada and National Research Council of Canada, BIM is increasingly contractually mandated, with BIM execution plans utilised by 43% of organisations. There was an article in Science Direct, and the study proved that BIM could improve PPP's performance by 28.9% on average. BIM provides better ability to monitor and control KPIs. Benefits of digitisation to FM productivity, success, for example, easy access to asset history, manuals, see site at the area before travelling, measurements, even see the wiring, pipes behind the walls. ISO in BIM is also popular in Canada, for construction at least. From this article, but a BIM mandate would provide adherence to ISO standards, so it's standardised across all projects globally. So what's standardised? It's defining information requirements and structure and how assets are classified, and standardise the processes.
It's interesting, Liz. It's amazing, 28.9% that has already been identified that BIM can improve performance.
Yeah.
So now if we look at outside Canada, one of the most important insights that we can get in Sweden is that clearly we can see a changing of ways and a change to how we work. And we therefore become more diligent with what we're doing. Information is more available. We can make better decisions. We have that information to actually base our decisions on. But we must identify what tools we do want to use and work with. So information can come from many different data sources, but for the end user, it must be available in the systems that they are used to working with. I'm going to turn this over to Mats, who's going to run through some examples that he's got of some of the implementation of systems live in Sweden.
Okay, thanks, Sam. I will see if we can share the screen here now and show a movie around this. This will show a little bit of a use case talking about, we call it the technician's best friend, and it's an assistant, an AI, generative AI assistance that we will work with. So maintenance and operation manuals should be a little bit of a concern in some organizations, that it could be like there are in binders or papers, it could be PDF documents, it could be stored in a document system, but it's not always accessible for the technician when he needs it. So he has to be, when he's out in the field, he has to have access to the right maintenance and operation manuals, and he have the right version of the document so he can fix the problem that comes up. In this case, we have just made a example of this. So we can see in the red mark there, you can see that is one of the things that has been coming up is the too high pressure in the ventilation unit. So the technician has to fix that ventilation units. Or instead of trying to get into the maintenance and operation manuals or read some documents, we can use ask the same question to this assistant and say that the high pressure of the ventilation units, and it search down in the documents that we have stored and give some answers to the problems that could be solved. So if this means that the problems that we can be solved with the information that we have received here, there will be questions for this. If the problems that you've been texting now, or the text that come up here, they will solve the problem. So that means that if there's thumb up for this, that it will solve the problem, we can send it back to the machine learning and say, the last time when this problem occurred, we can just say that this problem was solved with this information received. If not, we also learn that this text will not solve the problem. And then you can dig down and answer more detailed questions. And when you have learned and get the right answer, you just have to give thumb up or thumb down on the text. So you don't have to type everything that has reparated the problem. So in this time, we use the generative AI technology to really get to this point. And we can also take the approach of, for example, if you have a problem with in the room with warnings or monitored values you put up, it could be the monitored values for example, CO2 levels or pollutions, or there can be high temperature or other things that could cause. We can dig down to the details out in the field to help. There will be an alarm that will be alerted into QFM in this case. And we can dig into details, what's happened before, and we can look into all these details in time series to understand what's happened, and if there are problems that have been many times, and how the problem has been solved before. With all of this data that comes to that, we can learn about these processes and be helpful. And of course, they will also be able to minimize the deductions if we can learn from the data that comes before it has been broken. So with warnings, with alerts directly into the mobiles that you work in the CMMS system, with help of both IoT devices that send information, or generative AI that you can ask for problem solving or troubleshooting, is one of the things that we have now seen is really, really popular, is growing heavily now in Sweden, that they want to have that implemented in the solutions. Another thing that is quite common now is to see, because it's not mostly of the buildings that we have in the world is not yet digitized. So this is of course new buildings that comes into the market that have the best conditions with all the BIM models built in technology and everything, but 96% of the buildings are not yet digital. And that means that we have a little bit of a problem to really have the visibility of how the building looks like, the floor plans and everything, and we can work with the data as we want. And this could be, if you want to do this process, there has been quite a manual process. It could be quite expensive to digitize everything for existing buildings that have the visibility of what you would like to see in the operation and maintenance phase. But there are tools now that you can work with. So we can create BIM models with an AI engine that we call BIMify in this case. And we can take a floor plan to a BIM model by automatically. So from the beginning of, they have a floor plan from the beginning, and we call it fast track to digital buildings. And it's AI powered to use it. So from a work that should be taken up to 2 days for an architect for a specific building, we finished up now in minutes with this AI tool. And it's creating objects from this 2D drawing, identify if it's a door, if it's a window, if it's a room, and created these boundaries around the rooms and measured all the areas and everything around that. This will not be fulfilled directly, so we have to put some manual process into this to get it as a ready-to-use model. So there are, of course, some demands that we have to put in here to be able to deliver us fully. But approximately we can create and BIM up to 80%, then we have to put 20% effort in to create the full BIM model on this. And that is quite impressive, actually, to just learn an AI tool to create BIM models from could be from PDF or DVGs from the beginning, that it has floor plans from the beginning. So that is how we will use it. It could also use this engine from point clouds, for example. So there could be also when you laser scan things, and sometimes you don't have drawings at all, that you have to laser scan from the beginning. And then we have a process that we call scan to BIM instead. And this is an example from Sweden that we had done a sports arena in Stockholm, outside Stockholm, and demands from the customer, the requirements from the customer was to create an accurate digital twin, and they want to also have some communicative material to the society, to the municipality in this case. So there's different steps in them. The step one is the measurements of this, and to capturing in the reality with the laser scanning. So laser scanning, we have UAV for outdoor areas and georeferring the right location. So this laser scanning send out millions of points and catch how it looks like, and the result is a point cloud in the end. This is how a point cloud looks like, and it's not so easy to look into these point clouds, that you want to have a little bit more visibility of the point clouds, how it looks like. So when you're doing this scanning, you're also doing 360 pictures of everything. So there will be a representation like you look in Google Street View for indoor. So you can look at what they have scanned directly. And this is also the foundation to create the BIM models. We can create a BIM model from the point cloud. And you can use that different types of consultants or operation management can get into this data and use the BIM models for their behalf. When it's finished, we get this model accessible into the space management tools and into the CMMS systems to get accessible there. And you can, with color-coded layouts, look into different room types, for example, or it could be other things that you want to put out. All rooms are also connected to the point cloud. So if you click in a room, you call directly to the place in the BIM, in the point cloud that you can refer back to and look around. I will come back to that a little bit later in the presentation, how that could look like. And the last is that we can have a visualization. Now they have chosen to just be in white here, but of course there can be more color of it, also. And the delivery of this is about 11 weeks from start to end. So that was a little bit of the presentation around how we can use new technology also for existing buildings.
So, use case for elevators. It's about return on investment, and elevators are something that is in every building pretty much. So Mats has just given us some great information and some great examples of how we can get to this point where we're utilizing BIM and how to use the data. But just to take us through to the next step, though, Mats, do you want to explain a little bit more about an actual example using one of the elevators that you've got, that you've done some analysis of?
Yes, of course. So we have done a return of investment for elevators, just to when we see in a study that we have done, and we wanted to see if we could reduce the number of maintenance visits for the elevators based on how the elevator is used instead of how they will theoretically plan to be maintained. So often you have a maintenance phase that you can be visit every quarter or something like that, every week or every month. That can be on theoretical plans, but we wanted to see also if we manage to monitoring how the elevator is used instead, how much we can reduce time. And we just put up an estimation of the 10% using of the sensor data reductions we need on the site maintenance visits. And then we can just measure those on different things about finance, sustainability, and accessibility. And we can see that we have 60 fewer car road trips being made on the sites per year, and we find the finance savings about $39,000 per year, and the downtime on the elevators and escalators, and elevators is reduced by 120 hours. This is just one example of how it could be like. And it is a healthcare organization that have done this review of. They have 150 lifts in their portfolio that you work with. And if you lay that onto Paymac to predict failures before they happen, therefore minimizing deductions that improve the value. And the outcome of this that it may also mean that the technical lifetime of the assets for some of the elevators will be longer than estimated from the beginning. So you can say that the digital twin for modeling scenarios with a what-if operational maintenance strategies for improved asset value. So that is one of the examples that we can see that we did a scenario and you see explanation there are return on investments just on those cases that then can be implemented in scale.
Thank you, Mats. So there's some really good examples there. So I guess, Liz, what are some of the benefits to PPPs specifically that you can sort of comment on?
Okay. Benefits of a digital twin to a PPP are quite extensive. Sensors provide live asset data and reduce maintenance visits, saves money, more time for areas that need it. Operatives can see site entrances, exits, access points, and assets on an interactive floor plan, help plan site visits, and it's essential for large countries like Canada and Australia, and has the ability to do more with less.
Interesting. Very interesting. So our next point, sustainability in P3s. Sustainability is becoming a more common inclusion in contractual requirements. How, where, who impact all key questions and components of the contractual requirements. And they are what go into identifying and implementing a sustainability policy. We're going to open another poll and invite you to all participate in this poll, and it is looking at where can operational P3s or PPPs make the most sustainability savings. So you'll notice again, if you can have a look at the poll icon, the graph icon, and select there, and just let us know. We're interested to see what everyone is using, or what everyone's thoughts are, I should say, on sustainability and P3s. So we're tracking here through. Oops. So we've got approximately 85%. Got some quick mouse clickers managing the whole building life cycle, not just the immediate services. So very much, it's about that holistic approach, which is fantastic to see. All right. So just to jump back then, sustainability, as we know, there's a lot that goes into it. With the recent contracts, Liz, are you noticing that the market is definitely starting to push sustainability?
The P3 market is pushing sustainability, so not just saving money, but reducing their carbon footprint, which makes them more competitive. Another example I would suggest is contracts with multiple sites that technicians travel to, especially in Canada, where it is really vast. So focusing on the savings for travelling and managing time. We have a couple of contracts which are school bundles of 8 to 10 schools on the one project. A lot of new PPPs want to be the forefront of lowering carbon footprint, so increasing what they ask of their bidders to be able to provide to support that. Having a provider with a development AI and IoT would be an advantage. Dirty assets, identify them with IoT to take action.
Thank you, Liz. So we do have just one more video there that Matt has for us, which is around how we can use some of the technology. Matt, I'll hand over to you.
Yes, thank you. So, connected digital twin in this context, so I will show a little bit of overview how you can work with a scanned model in the operation and maintenance phase of a building. So get direct access data to sensor data in the buildings and different assets in this case. So this is the central station of Stockholm, Sweden, and this is a 3D scan that you saw before when I saw the scan to BIM that I showed you how we done for an existing building. This is a project that we have done for them. And in this point cloud, you can do measurements and you can do some planning and how things looks like before you go out on site. To say this from a sustainability approach, you minimize the road trip to get to assets, to understand what to bring to site when you're going to there to fix some problems. You can review and look into different rooms and how it looks like in reality, in a virtual reality, actually. So in this case, we have also put it out. So this comes from the BIM models, the asset that has been coming out to the models, and put down some point of interests. And we direct get access to the sensor data. So this is the rotation doors that we can review then how the running time of the data, the startups and the things. We can see the indoor temperature, the outdoor temperature, and it's also correlated with weather forecasts, the Swedish National Weather Forecast. That is how the weather forecast can do and how doors will be affected or how temperature will be affected in the house. In this case, a search also just search for sea pumps. That is for cooling of the central station and can get access directly to the pumps down in the basement of central station of Stockholm. And at the same time here, I can click on that and get access for a serial connected pumps here, so we can see some time series on the intensity and temperature and so on, related to outdoor temperature and how the cooling should act. So that is another example of that. We can connect to conference room and look into like behavior sensors or environmental sensors. They can look also into the conference room, so that could be also one of the things that could be addressed. So that was just an example that you can work with a connected twin with using the point cloud actually in the maintenance and operation phase and get a really simple user interface. It's like working in Google Street. You can walk around the building and search for different rooms or assets. So back to you.
Thanks, Matt. I think just in the interest of time, we appreciate that everyone has joined us for an hour today, and we're bang on that, just a smidgen over. So we did have some time allocated to Q&A, but again, in the interest of time, if we wanted to pop some questions into our chat here, or Adam, I believe you have some contact details that we can also use as well.
Yes, correct. Sorry, we're having some technical problems. I'm just trying to join the stage. Can you speakers hear me?
Yes, we can.
Yes, okay. We can hear you, Adam. Go for it.
I believe Samara is trying to add me onto the stage. But my suggestion for the question that came in the Q&A field from Munzungu and Zadio is that we provide an answer and send that to the group via email. Just because people need to wrap. So if you three could put your thinking caps on and put together a nice answer for Munzungu, then we can send it to everybody, so everybody can benefit from the insight into the question. I have some other bits I was going to flag, but I know that people need to get on to their next things. So I'll just take this opportunity to thank all three of you, Matt, Samantha, and Liz. Thank you so much for your amazing presentation. It was I think, very, very interesting and enlightening. I look forward to hearing what our audience thinks as well. And thank you also to the team at ServiceWorks Global. I know a lot of work went into this, so it's been fantastic working with you. Also, thank you to our audience for joining us today and giving us your time. I hope you found it. I hope you enjoyed the session and found it valuable. We'll be in touch with some updates. For now, that's it from me. That's it from us. Thank you so much for joining, and enjoy the rest of your day.